Okay, we're going to give this a try again here, see if we can get this correct here. So this is exam 3 here that we're looking at. Again, my first question here is we're looking at finding the vertex and my x-intercepts if there are any. And so let's do this thing. So that first equation, if you guys looked at that, that's 1/4 x squared plus 1/3 x and then plus 2/3. So I want to find my vertex. My vertex is h and k. My formula for h is negative b all over 2a. So for this one, I'm going to go negative 1/3 all over 2 times 1/4. 2 times 1/4 gives me 2 over 4, which is ultimately 1/2. Right? And so I've got negative 1/3 over 1/2. So I flip and multiply. So 2 over 1, that can come up here, and I can multiply straight through, which would give me negative 2 over 3. This is h at that point in time. Okay, now I need to find k. To find k, I'm going to plug that into my equation. So 1/4, then negative 2/3 squared plus 1/3 times negative 2/3 plus 2/3. So just work through this methodically. If I square both these, that's going to give me 4 over 9. And if I times by 1/4, that gives me 4 over 36, which simplifies to 1/9. The second one will give me negative 2/9. And then I've got the plus 2/3 there. And 2/3, if I want my denominator to be all the same, is really just 6 over 9 is what I want to use for that. And then I just add and subtract my numerators. 1 minus 2 is negative 1, plus 6 is 5, so we'd have 5/9 here. So my vertex is going to be at negative 2/3, and 5/9 is what I'll have for that. And then while I'm at it, I'm going to find my x-intercepts for this as well. To find my x-intercepts, I'm going to use my quadratic formula. So negative b plus minus the square root of b squared minus 4ac all over 2a. So we're going to go negative 1/3 plus or minus the square root of 1/3 squared minus 4 times a times c. And then that's going to be all over 2a. Well, 2a was just 1/2 when we did that. So 2 times 1/4 is 1/2. Okay, and so now just simplify. This gives me 1/9. I'm going to simplify underneath. And then for this, I get 8 over 12, 4 times 1/4 times 1/3 there. So that's what I get for that as well. So, which that just simplifies. If you look at that, that just simplifies to 2/3 is what I get for that. So this is 2/3 here. When I combine those, though, I need this 2/3 to have a 9, so that's 6/9. So 1 minus 6 would give me negative 5/9. And this is an issue, guys. Usually these would be my solutions and I'd be okay, but when I take the square root of a negative number, that means it's imaginary and it's not going to cross the x-axis. So there is no x-axis here. So when we go to type in our solutions here, my vertex, again, I just had that. That one was negative 2 over 3. And then the other part of that vertex was 5 over 9. And then because we don't have any intercepts, I'm just going to go NA. If you did, then you could just put the bigger and the smaller one in like this. You do a plus and the minus for that, and it would fit in just fine. So that's question 1. Okay, so you're going to use quadratic formula for that, and we can get a solution on that one. Okay, question 2 is going to want me to take this vertex that's at negative 4, 3, or negative 3. That's my h and my k. And then I've got a point 0, negative 1, and I'm going to use that form to find my equation, and then I can use that to find my y-intercept as well. So if you guys remember, we use this formula, y equals a parentheses x minus h squared plus k. It tells me h and k. Again, if you go back to that question, h and k is this point, that's the vertex, h is -4, and k is -2, and then this, or sorry, -3, and then this is just an xy point here. So we're going to go -1 for y. I don't know what a is, that's why we're doing this. 0 for x, -4, which becomes +4 here, squared, and then -3 is what I get. And I'm just going to solve that. I'd add the 3 over here, which would give me 2, and then I'd go 0 plus 4, which is 4, and then I'd square it, which would give me 16. So this is 16a. I'd divide that over here, and I'd get 1/8 is what a is. So my equation is going to be y equals 1/8, and then x plus 4 squared minus 3. That's the equation that I'm going to want to write for my answer in that case. Okay. Again, we want an equation with an x and a y in that case. Right. Then I do want to find where it crosses the y-intercept. So the y axis or the y-intercept. To do that, I'm going to plug in 0 for x. So this would be 0 plus 4 squared minus 3, and that'll tell me where that crosses at. So this will be 4. Squared is 16. 1/8 of 16 is 2. Minus 3 gives me -1. So I'd have y equals -1. That's where my intercept is as well in that case. Okay. So I just go back here. We're going 1/8. And then x plus 4 squared and minus 3. And then for here, I'm just going to enter that value in. That was -1 is where that was. That's what I get for that. Bada bing, bada boom. Okay. Moving on. Here's our next one. We're going to use some long division in this case. And it just wants us to write out my expression as I go through that. So we've got 3x to the 4th minus 2x minus 10, and then all over x squared minus 3. Okay, and so when I go do my division for this one, remember we're going here, and underneath goes my numerator, so 3x to the 4th minus 2x, so I'm going to go plus 0x to the 3rd plus 0x to the 2nd. It just helps me keep my order of things correct. If you don't need it, then that's all right. And then out here I've got x squared plus 0x minus 3. So I need what times x squared will give me 3x to the 3rd. That'll give me 3x squared. And I'm just going to times that to everything. I still get 0x to the 3rd. And 0x squared and 0x here. And then here I'm going to get, whoops, hold on just a second. That is not correct. I got ahead of myself. This is actually going to give me negative, oops, come on, change, negative, so there we go. Now it wants to erase the whole time. That's interesting. Let's do this. Hold up just a second. So, sorry, we've got, let's see here, we've got 0. It just does not want to function here. That's funny. So we've got plus 0x, if this ever wants to work here. We'll erase that. How about that? Okay, so sorry about that. I think I got that figured out. So this gives me plus 0x to the 3rd, and then minus 9x squared. Then I'm going to subtract everything. That cancels that out. This becomes a positive 9x squared. Drop everything else down. And I'm going to say, what do I got to multiply to x squared to get 9x squared? That'll be positive 9. And so I'll get 9x squared plus 0x and minus 27. then we're going to subtract everything. That's gone. I've got negative 2x here, and I've got positive 17 that goes right there. So now my answer is 3x squared plus 9 plus negative 2x plus 17 all over x to the second minus 3 is what I'm actually going to have as my final value there. So we're going to go type that in. Just got to write it down here. Okay. Here we go. So 3x squared plus 9 plus negative 2x plus 17 all over x to the second minus 3. Bada bing, bada boom. Okay, next question. We are looking at this graph. Again, a couple things. I know that where it's touching right here, that means that I have a multiplicity of 2, so there should be a squared on that one, and it's to the left, so we're going to have a plus sign. And where it goes through, there should be 2 positive values. And then this thing's facing upwards, so A should be positive in this case. And so what I'm really wanting to look for in this is I should have A, and then I should have 3 sets of parentheses. One of them should have a squared. Again, x here, x here, x here. Again, this doesn't matter where this is, but this was in the negative place, so this would be positive. And remember, the signs flip, and these would both be negative. So we're looking something to that effect, because when I look at this, this is, again, should be negative in the parentheses. You should be, or sorry, positive in the parentheses. You should be negative. So as I scroll down through here, I can ignore all the negative values in that case. So I don't need any of these. I believe it's this one because, again, these 2 factors come from here. And then I've got the squared on that one. So that one right there, that third one down. So I don't have to go very far. I know you guys love these questions. They're like your favorite of all time. So, okay. Moving on, looking at the next one here. I'm looking for all my rational zeros, or my rationals here. So I'm going to look at my equation, that 3x to the third plus 10x squared plus 6x and then plus 1. I have to use my rational zero theorem to tell me what possible zeros I have for this. And so I take the factors of 1, which is just 1, and then the factors of 3, which is just 1 and 3, and that tells me possible ones. Okay? So again, my possible ones are 1 over 3, and then 1 over 1, and we're going to have positive and negative for both of those. Okay? These are possible ones. They're not the exact ones. We're going to actually use some synthetic division on this to see. And so when we set this up, we go 3. Again, my equation is 3x to the third plus 10x squared plus 6x and then plus 1. So I'd have 3, 10, 6, and 1 here. No placeholders. And I'm just going to pick one of these to go in here. So I'm just going to put the negative 1 in here just for kicks and giggles. Again, you could put 1. I like putting whole numbers first just because it's easier. 3, so that gives me negative 3. This gives me 7. This will give me negative 7, which will give me negative 1, which will give me positive 1, which will give me 2. So that's not 1. So I'm going to try it with 1. I got to have 0 as my remainder is what I end up needing to, okay? So 3, I get 3, I get 13. We get 13 here. That gives me 19, which gives me 19, which is going to give me 20. So that's not one that I want. So let's go 1/3. So here 3 goes down. I get 1. That gives me 9. That gives me 3, which gives me 9 again. Oops, sorry. This gives me 11. Hold on. Hold the phone. So this gives me 11, sorry, which would give me 11 over 3, which is going to give me some other fraction, which I don't want. So this is probably not a value that I want at this point in time. So Hold up just a second. So again, that gives me 11 over 3, which is going to give me like 6 and 11 thirds. And so you just kind of get a mess there. So we're going to try negative 1/3 and see what that gives me, okay? So 3, 10, 6, I probably guessed wrong then on these, and that's okay. Negative 1 here, that's going to give me 9. That'll give me negative 3, which will give me positive 3, and then that'll give me negative 1, which will give me 0. So that is one of my zeros, negative 1/3. It just happened to be the last one that I checked. And then I have 3x squared plus 9x plus 3. I need to factor this, so I'm going to times a and c together, which gives me 9. I need two numbers to multiply to 9 and add to 9. Well, if I think about that, there's probably not two values, so I'm going to use quadratic formula. So we're going to go negative 9 plus minus square root of 9 squared minus 4 times 3 here. And then that's going to be all over 6 at that point in time. I'm going to find out what I get from doing that right there. What's underneath the root is what I'm looking for. Okay, so I'm going to go 9 squared minus 4 times 3 times 3. And so that's going to actually give me 45. So I have negative 9 plus minus the square root of 45 all over 6 still. So I would just leave it like that. Let's see what we get from there, and those would be your two other values that we'd get. We're going to go smallest to lowest, which if you think about this, the square root of 40, that's going to be 45 is going to be something like 6 point something. So we just got to go from least to greatest in that case. So we've got our negative 1/3, and then we've got our positive of this. So we've got negative 9 plus square root of 45 over 6 and minus as well. So, okay. So here we go. You ready? Here's how we're going to enter these in. We're going to go here, and so we'll have our negative 9 minus, oops, I need my fraction key first. So negative 9 minus square root 45 all over 6. And then we'll have negative 1 over 3. And then we will also have negative 9 plus square root of 45 over 6. Whoops, I got to put them in the other ones. Somebody out there is being like, hey, dummy. And here we go. Negative 9 plus square root 45 over 6. We saw this stuff. Oh, crap. Let's see what it wants. It wants not that. So, hold on just a second. Let me go check my work here. So we got negative 1/3. That looks good. Let's go make sure I've got what I need here. So, making sure here we've got 9 squared minus 4 times 3 times 3. So, just a second. Okay, so actually, guys, I apologize. This, I need to read the instructions. It wants just rational zeros. This negative 9 minus the square root of 45 over 6 is an irrational, and same thing with the other one is an irrational. So that's why they did an NA, because they only want rational zeros, not the other one. So it was just going to be negative 1/3. So that's one that I'd actually probably fudge if I needed to here. So, okay. All right, our next one here, we're looking same thing. We've got to do here. I'm looking at this. Looks like it goes through negative 1 and possibly 1/2 and some other value here. But we're going to do synthetic with negative 1 is what we're going to do with this. Okay. So we've got 2x to the 5th plus x to the 4th plus 5x to the 3rd plus 5x squared minus 2x minus 1. And so, again, I'm going to go back here, and we're going to use negative 1 in this because that's where it looks like it crosses at. So 2, 1, 5, 5, negative 2, and negative 1, and do synthetic. So 2, negative 2 here, negative 1, that gives me 1, gives me 6, gives me negative 6, gives me negative 1, which gives me 1, which gives me negative 1, which gives me 1, which gives me 0. You can have a multiplicity of 3, so I would check this again to see if it gives me another factor of 0 here. So 2, negative 2, negative 3, 3, 9. This looks like it's not going to, so negative 9, negative 10, 10, and 9. So this one does not. So negative 1 is one of my zeros, okay, which is awesome. Here's the route I would probably go, because if I go back and look at this graph here, it does look like it crosses at 1/2 as well. Okay, so I would go check and see what that one gives me at 1/2, because that sure looks like it should. We should have 5 zeros here. And so we would go and try that one as well. So yeah, so let's do that. So I'm just going to erase all this and all this here, and we're going to do positive 1/2 here with this one. So 1/2 here, when I drop that down, I multiply, that gives me 1, gives me 0. For this one, I get 0 again, 6. Half of 6 is 3, which gives me 2. Half of 2 is 1, which gives me 0. So that's awesome. That's what I'm hoping for in that one right there. Okay? So should be good. Everybody should be pretty good there. This gives me an x cubed squared, x term, no term there. So what I would do is I would actually double check this, make sure 1/2 doesn't have another multiplicity of anything. So again, I'd go down. We're going to get half of that, which is 1, which will give me 1. This will give me 1/2, which will give me 5 halves, or 5 and 1/2, I should say, which is just 11 halves. When I multiply those two together, that becomes, again, that becomes like 11 over 4, which is not going to give me 0. So this one's not going to. So I have one at negative 1. I've got one at 1/2. And then if I go back to my graph here, it also crosses right here, which that one's not on a whole number or anything like that, so I'm going to imagine that's probably going to be an irrational one. So right now, if I look at this, I have 2 rational zeros. So we go 2 there. I'm pretty certain we've got 1 irrational, which means at that point in time, the other 2 have to be imaginaries from there, okay? Because I have to make up 5, and I can't find any more after that. Okay, this next one we're going to do synthetic on. I've got x to the 4th minus 4x to the 3rd plus 2x squared minus 12x minus 3, and then I know I've got square root of 3i. So they should have four of them on this. So again, we're going to do our synthetic on this, but in my box is just my imaginary. I'm going to put the I out front because it just helps me with things. 1, I would suggest putting a little more space at these when you're dealing with imaginaries. 2, negative 12, and negative 3. Drop the first one down. When you multiply, you get I squared of 3, which gives me negative 4 plus I squared of 3. When you times these things, I'm just going to make a little bit of note here. This still gives me negative 4I squared of 3 when I times those two, but I'm going to times I squared of 3 times I squared of 3, which gives me I squared square root of 9, which essentially gives me 3, and negative 1, which gives me negative 3 for that. So then we can add the 2 to that, which will give me negative 1, and then minus 4I squared of 3. Then I multiply again. That gives me negative I square root of 3 from that one. And then I get 4I times I, which gives me 4I squared. And then the square root of 9 again. This will give me negative 4 times 3, which will give me negative 12. Negative 12. Okay. Sorry, I said negative 12. I said this should be a negative 4 right here. Okay, because I've got negative 4I times I, which gives me negative 4I squared. This gives me 3 times 4, which gives me 12. So this is a plus 12. Those cancel out. I'm left with just negative I squared of 3. I times those two together, and I get negative I squared square root of 9, which just gives me 1 times 3, which gives me just 3, which is what I want. And then I have to do negative I square root of 3 here, because they always come in pairs. So I drop the 1 down. I get negative I square root of 3. Those cancel out. I get negative 4. When I times those together, I get negative 4. Actually, I get positive 4. Sorry. I get 4 I square roots of 3 because of the negative, which gives me negative 1. And then that's going to give me positive I square root of 3, which is going to give me 0. So that's awesome. That's what I want, because then I've got this quadratic that's x squared minus 4x minus 1. And so I'm going to use my quadratic formula for this. So negative b plus or minus the square root of b squared minus 4 times a times c. And then that's going to be all over 2a, which is just going to be 2. Take care of what's inside here. I get 16 plus 4, which is going to give me 20. So I get 4 plus or minus the square root of 20 all over 2. I'm pretty certain you can leave it like that. You actually do not have to simplify it that way. So I've got, those are all my different values. I get all of those, okay? So when I go to enter my solution, I have to separate them with a comma for all of them. So we're going to go here, we'll go 4 minus square root of 20 over 2, comma, 4 plus square root of 20 over 2, comma, we have the square root of 3i, comma, and negative square root of 3i. And bada bing, bada boom. Almost there. Next one here, we're looking for holes. In this case, remember when we have a hole, when we actually factor this thing, and if I blow this up, so that's x squared. Just make sure here. So we have x squared plus 3x plus 2 all over x squared plus x minus 6. So when I go to do this, I need repetitive factors here. So I've got x squared plus 3x plus 2 all over x squared plus x minus 6. So when I go to factor this, my numerator is going to factor to x plus 2, x plus 1. And my denominator is going to be x plus 3, right? And x minus 2 for that. So I don't have any repetitive factors, so there's going to be no holes in this one because there's no repetitive factors. So we're going to go NA and NA for this one. Okay? Only when you have repetitive factors, and that's where your value is going to be. Okay? All right, next one, I'm looking to draw my vertical asymptote. Again, I need to factor this numerator to find out where we're looking at here. So I've got 3x squared plus 12x minus 15 all over 2x minus 3. So we're going to head back to this page here. Again, I have 3x squared plus 12x minus 15. So I'm going to try to factor that. That would be most useful here. When I factor this, I'm going to times 3 and negative 15. That'll give me negative 45. I'm looking at two numbers. Then multiply to negative 45 and add to 12. So if I go 15 and negative 3, that'll work. I have to divide it by a, which gives me 5 and negative 1 for that as well, which I actually should just take out a greatest common factor first. So I apologize. This is actually what it should look like. 3 and then x squared plus 4x minus 5, which then that would factor to 3 and then x plus 5 and x minus 1. And this is 2x minus 3. So if I look at this, my vertical asymptote is going to be here, what makes this equal to 0, which this denominator equal to 0, which what makes this equal to 0. I'd add the 3 and divide by 2, so x would be 3/2. So I'm going to have a vertical asymptote at 3/2 here. So when I go back to here, my vertical asymptote, I'm going to draw my line here, is at 3/2, which is 1 and 1/2. So 1 and 1/2 right here. I'm going to have a horizontal asymptote. If it's bigger on top, that means there is none. So I don't have to worry about that. And then what I do need to do is find where it crosses the x-axis. It's going to cross the x-axis. We set the top or the numerator equal to 0. Which essentially I'm just going to have whatever makes this equal to 0, which is negative 5, and that one. So negative 5 and 1 would be where it crosses my x-axis. So I'm just going to do a point for that, negative 5 and 1. Correct? Make sure I got it, negative 5 and 1 here. Okay. And yeah, so there's no horizontal asymptote, so I don't have to draw that one as well. Last one, I'm looking for my vertical asymptotes again. Again, I'm gonna factor that numerator. So here we go. So I've got 5x squared minus 5x minus 10 all over x minus 3. I've got to take a 5 out of there, which gives me x squared minus x minus 2. And then that will factor to x minus 2, x plus 1 is what I end up getting there. Then I've got the 5, so not that. And then I just have the x minus 3. No holes because I don't have repetitive factors. I have a vertical asymptote at 3. And then I have it crossing the x-axis at 2 and at negative 1. So if I go back here, I need to graph vertical asymptotes. Again, my vertical asymptote would be at 3. So boom there. And then my oblique one I'll find here in just a second. The points where it crosses the x-axis, I just said that was 2 and at negative 1. At 2 and at negative 1. Whoops. Don't want the line. Got to switch it to there. 2, negative 1. And then I've got to find my oblique. To find my oblique, I have to divide these two. So we're going to go 5x squared minus 5x minus 10 divided by x minus 3. I have to times this by 5x to get me 5x squared, then minus 15x. I'm going to subtract this. That gets rid of that, which will give me 10x minus 10. And then I have to multiply this by 10, which that'll give me 10x minus 30. And that'll give me 20. I don't care about my remainder. This is my oblique. It's y equals that. So it's going to cross the intercept at 10, and it'll go up 5 over 1. Okay, so it's going to be here at 10 is a good place. And then usually I go up 5 over 1, but I can't that way, so I'm going to go down 5. 1, 2, 3, 4, 5. And then I'm going to go over 1 this way. And that'll give me my oblique one. So, okay. That's there. Sorry about the little glitch on the one with reading rational, irrational. So, that in your math moment with Mummy. Adios.